Alright, the last part of the investigation focuses on what happens if we have a number inside of parentheses and then we raise that to the second power. So we're still dealing with a quadratic, but now we're looking at how it shifts. So again, we're going to plug in our values into our equation and see what comes out. So a trick that you might have forgotten would be using your calculator to help you complete the table and graph. So if you hit y equals, and you clear out what's ever in that equation, type in what we have. So we have parentheses x minus 5. And the parentheses do matter. Hit graph. If you don't like what you see, hit zoom and then 6. That gives you a nice set for the window. Alright, so I kind of get a sense of it, but I want to be accurate with my graphing, so I'm going to complete this table. On your calculators, remember if you hit second and then graph, it gives you a table. Now I don't want just any numbers, I want the numbers that are listed on my table, because those are the ones that I'm going to be able to graph with. Okay, so starting at -2, I've got 49, 36, 25, 16, 9, 4, and 1. I'm going to make some new rows here because we're not seeing all the numbers we need to see, and I'll make you see why in a second. So I'm going to continue past 4. I'm going to get 5, 0, 6, 1, and 7, 4. You can actually do one more. 8 will give us 9. Alright, because see what happens when we try to plot those points. If I use the original -249, that's not going to fit in my graph, so it doesn't really help me. Either does -1, 0, or +1. None of those graphs or numbers are going to help me on my graph because I can't plot those points. So I'm meant to focus on this bottom half here. So it's important that you understand the data when you're looking at it and how to use it. So here I have 2, 9, 3, 4, 4, 1, 5, 0, 6, 1, 7, 4, and 8, 9. Remember, for a quadratic, you should see that symmetrical or same positions on either side. And we'll talk about that as we work with quadratic equations. For now, we're just focusing on how this graph has changed. So if I line up my transparency, what's the difference between this graph and this graph? Well, clearly this graph was shifted, and it's shifted to the right. And you can see that if you slide it over, and it lines up perfectly. So in this problem, the value of h was -5. And how did h compare to the regular graph? It moved it to the right 5 spaces. Okay, where is the minimum point on this one? Well, remember, minimum is how low it goes, and the lowest point on this guy is 5, 0. And does this one open up or down? This one opens up because it's a positive equation, so it's going to open up. The tricky part with this is that if you think of -5, you would think you should be moving to the left, but inside of the parentheses you actually do the opposite sign. So in this case you move to the right 5. Let's look at another example. And here it's going to incorporate some other stuff that we've worked on. Part B throws in a negative in front of the x value as well. So again, I'm just going to use my calculator. Y equals, remember you hit y equals to get to the screen. And type in your equation exactly as you see it with the parentheses. Those matter. Let me retype that in. Okay. Graph it so I can get a sense of what it looks like. So hopefully you remember from the first video that the negative in front of the equation flips it. So this is why this is upside down. Kind of like a hill or an arch. To get the table, I just hit second graph, and I'm going to look for these specific numbers. I want to start at -6. So now I can plot those points onto my table. -6, -9, negative 5, negative 4, negative 1, 0, negative 1, negative 4, negative 9. So here I can plot my points, negative 6, negative 9, negative 5, negative 4, negative 4, negative 1, negative 3, 0, negative 2, negative 1, negative 1, negative 4, and 0, negative 9. So with this graph, let's see what happens. So not only am I moving it left or right, I also have to flip it. So I'm going to flip it, and then I shift it to the left, and that's how these match up. So that 3, the plus 3, is making me shift to the left. So the value of h in this equation is 3. And how did h compare to the graph? Well, it moved it left 3 spaces. In this problem, we have a maximum because this is as high as you can go on the graph. So the highest point I can go is at negative 3, 0. Does this one open up or down? This one opens down because it's negative. Now that you've done all the transformations, see if you can do the summary page of what each letter does to an equation.